All right, so welcome to our free LSAT prep hour for January 24th, 2021. My name is Dmitry Farber and I will be your host. As I was saying before we started recording, this is a follow-up on my earlier lesson on LSAT speed strategies. We've also done specific lessons for reading comp and LR if you want to check those out on YouTube. Today is all about logic games, so let's make sure we have our principles in place. All right. General idea, we want to make sure we have some strategies that work for us on LSAT in general, and then going to work on some specific things you can try to make things go a little bit better for you. Okay, so some broad strategies. We've used, we use these broader areas for the other workshops as well, and so I'm just gonna go through these a bit more quickly. General principles to use here. First, make sure that you're front loading your efforts. And what I mean by that is make sure that in general across this test, you're putting more work in at the beginning and less work jamming through the answers at the end. Later on, you'll see avoid unneeded work. These go together. The more I can understand the passage at the beginning, the argument, the game, the better I have a setup, the more efficiently I can work through the answer choices when I'm on the back end, and the less hard work I have to put in. So that usually means recognizing the right kind of game, knowing how to set up for what I need. Often that'll involve frames. I'm not going to get deep into framing today, but that's one of our core logic game strategies, is making sure that when you have a game that breaks down one of 2 or 3 distinct ways, that you're breaking those out in advance and seeing that. You also want to make some really good predictions. That can be framing. That can also be framing within a question. One of my colleagues, Scott Miller, has done several sessions on the idea of using hypotheticals, which is a similar idea. Let's try some things out. Let's see what could happen. You also want to make some inferences as you go. You don't need to make all your inferences up front. If there's something that comes to you later, filling that in and adding that to what you understand. The third and fourth ideas work together in the idea of not doing more work than you have to, recognizing the bad answers, recognizing when you need to drop something and move on. There's also an element of deferring in the sense of, if I'm not sure whether I can prove an answer, if I feel like maybe it's possible, but I want to try some things out, let me move on and see if I can eliminate some other things. If there's 4 that must be false, then who cares whether I prove in detail that B must be true? The others are all wrong. Whereas if I've got 2 that both seem plausible, I might need to see which one can actually work. Okay, and then we're not going to spend much time on the last item today, which is thinking in conditionals. It's a very important skill for the LSAT. It's not one that we're going to focus on today, but making sure that you're good at setting up conditional problems and that you're not trying to use conditionals as a basis for framing. The basic idea there is, if I know something like if A, then B, that leads to a logical inference we can make called the contrapositive. Does anyone know what the contrapositive is of this? If I know that A leads to B, or when A is true, B is true, what else do I know? I know if it's not B, then it's not A, right? Okay, so I put these together. They're the same thing. They're not 2 different facts, they're the same fact. It's simply saying, hey, if every time Arlo is there, Ben is also there. That means if I don't see Ben, Arlo must not be there. Those go together, right? This is going to be tough to frame though, because I don't really know what's going on. I know that if Arlo is there, right, if I have sort of an in-out table, I know that if Arlo's there, then Ben's also there. And if I know that Ben is out, I know Arlo's also out. But this would be a really bad frame right now. Can anyone tell me why? What's the problem with this? Are these the only 2 ways the game can work out? Yeah, it looks like either they're both in or they're both out, but we don't know that. If A is out, I don't know if B is in or out. B could be in either place, right? Or if I look at it the other way, right? So I don't know what happens when A is out. I also don't know what happens when B is in. If I try to put B in, is A in or out, right? I don't know. So these would look like frames. Hey, they're in or they're out together, but that's not what it says. Now, if it says, you know, Arlo and Ben are always together, that means if they're both in, you know, they're a chunk together. And if one of them's out, the other must be out. That would be different. That would be a frame. But that's more like a chunk. These two are always together. So conditionals are a tough thing to frame, as we'll see. Framing can be a very powerful tool. We have it, but we don't want to fake ourselves into thinking we have it. So with that in mind, let me give you an exercise to try. I'm going to give you 10 rules. And the idea is, of these rules, which 3 are the most likely to result in frames? Without more information, without the entire game setup, I can't say whether you should frame these or not. These are just abstract rules. But the idea would be, of these rules, which are the ones that are most likely to lead to a framing situation? So take a minute to try this and see what you think. Okay, what do we think? Which of these rules seem like they might lend themselves to framing? All right. I'm seeing the first one, P is third, Fry is first. All right, so it's a tricky thing. P is third is a tough one because it just tells us one fact. So imagine you have, you know, a diagram. You know, here is 1 spot, 2, 3, 4, 5, 6, something like that. It tells us P is here, but there's nothing to frame right now. I don't know what else I'm dealing with, right? What else to put in, right? So I can't frame that one. R is immediately after S or R is immediately after T is tricky. I know that I have S R or TR, but I don't know which one. And I could see that as a binary choice, but I don't know where to put it. I don't know how to build a diagram, right? So those aren't going to do much. Someone said the FI for one. That's really interesting because with that one, I know if F is not first and I is first, then I know I have a binary choice here, F or I. And so in that case, I'd have to frame that because, you know, I don't have to frame it, but I'm likely to be able to frame that because one or the other has to go first and other things might flow from that. It's possible there's not much to do with that. I might just write that rule, but if when I know which one is first, something else happens. For instance, let's say J comes immediately after I, or you know, if F occurs, then F is after Q, and then I say, ooh, so if F is first, then Q's not there, you know, that kind of thing. Then that could lead to a really good frame. What else might frame here? What else might work? Any ideas? The LU rule. The LU rule is really interesting because it says L and U must be 2 spots apart, which doesn't mean they have 2 spots between them. It means either I have L and a space and U, or U and a space and L. And I don't know which is which, but that creates several possibilities. Now, how well this is going to frame is going to depend on how many spots I have. If I don't have a lot of other information and I have like 8 spots, then there's so many ways this could go. I could have L in first, L in second, L in third, blah, blah, blah. But if I have a fairly narrow game, there's a game involving saxophonists that we sometimes teach in class, where maybe I can combine this with another rule. This could make very profitable frames. And so anything that gives me an exact space gives me a pretty large chunk. The same thing is going to happen with this one. This one has an order. Hillary is exactly 3 spaces after Faye, so that would look like this: 1, 2, 3. 2 in between, 3 total spaces after. And that's going to usually have a pretty limited number of placements. Even if I have, say, a 7-spot game, then Faye is either first, second, or third. If I have any other restrictions, it might even be fewer than that. So that can get down to 1, 2, well, not 1 probably, but 2 or 3 placements for that chunk. The others are tougher. If L is third, K is second is a conditional. Or sorry, if K is second, L is third, I should say. That's a conditional, and it's hard, as I said, to frame those. M and R must be after J just tells us an ordering cue, but it doesn't tell us a decision to make. Kaylee is immediately before or after Rebecca is this, but there's less restriction you see from that than one with like the LU rule that takes up more space. So it's slightly less likely to be a framing opportunity than the other one, although I've seen games like the one I mentioned where these might combine. J is always first, doesn't tell us anything. It just anything that we can play with. It just puts J1. K and P are both later than Y. It's just an ordering rule. And then here's another one that gives us an ordering rule, so that's not going to be as useful. So what we want then, we want the ones that give us a large chunk that we can limit in its placement, or something where I have a nice binary decision like which is first, F or I. Okay. Questions on that? Is that all right? So this is one idea of framing. Obviously, there's a million things we could do with this, and one of the reasons I did the games edition of this last is that I feel like it could be a 7-hour workshop instead of just a 1-hour workshop. There are a lot of things we could do with these games, but getting comfortable with when to frame and how to frame and why to frame is a valuable part of getting better. Another thing that will come up a lot, and this is sort of related to the idea of framing, is the concept of number arrangements. How many of something can there be? How many times does something occur? And this is a very powerful thing to do that is related to framing in the sense of it helps you think about what's possible in this game, what we might be able to do, and what we can't do. So what we'll often see is there will be, say, maybe there are 5 teams, and how big can each team be? But how many total people are there? So let's actually just think about that for just a second. If I have 5 teams, and I have, let's say, 9 people, and let's say each team has to have someone on it, because otherwise it's not really a team. What possible team sizes can I have? So what could I do if I have 5 and 9? 9 people are going on to 5 teams. What's the biggest team I can have? What's the smallest team I can have? What kind of arrangements can I get? Okay, so it seems like I could have all 2s and a 1, so I could try to even it out as much as possible. And I'm saying some people say I could get up to 5. So if I have 5 people on one team, I'd have to have 1 on all the others, right? So 5, 1, 1, 1, 1. And so as we can start with that sort of greedy idea. And what we could do is we could sort of distribute it down, right? I could say, all right, well, I could take one of the people off of that big team and put 2 somewhere else and do this. And so we can sort of run out the math this way. I say, okay, I could have 5, 2, 5, 1, 1, 1, 1. If I don't max out one of my teams and I just have 4, then I could put 2 on 1 and I could keep going with this, right? Now I could say, all right, I could also have 3, 2, 2, 1, 1, right? 3, 5, 7, 8, 9. And I could keep building this down and spreading that out. I can keep making 2s. But notice I can also kind of reclump this, right? I could also have 2 3s, 3, 6, 7, 8, 9. Okay. And I could keep going all the way down until I get to, I could have almost all 2s. So you can kind of do this methodically in the sense that you gradually add more and more, moving from left to right, almost like you're running an abacus, right? So I could keep going with this and build the other combos. But there's actually not that much left, right? What else have I left out? Anything? So good question. Let's assume that there's no other repeats or anything like that. So assuming that we have everyone on and the game, and I'm glad people are bringing this up, right? A game will always be more specific than this. This is just a real off the cuff one, right? A game will always be specific. Let's assume that everyone's on a team and all the teams actually exist. All the teams have people on them, right? So if I left out any possibilities, let's see. I mean, obviously I can move where the 2s are, so if these were teams like A, B, C, D, E, I'd have to think about, okay, maybe team E could have 5 people, et cetera. But if I'm just thinking about pure numbers, then I'm kind of running out of possibilities, aren't I? Right? If I don't have 3, 2, 2, and I don't have 3, 3, 1, doesn't look like there's a lot else I can do. Okay. So that's our idea. And we're just sort of gradually working that out, right? So someone's asking, what's the purpose of knowing the number of arrangements? That's a really good question. Often it limits what we can do. When I have a small number of arrangements, I can actually frame it, and I'll show you some examples of that in just a moment. In other cases, it's simply a matter of saying, okay, what can my groups look like? It's also when I'm trying to draw a chart, how many boxes do I make? Let's say they've told us something like there's a maximum of 3 people per team. Then suddenly these are no longer possible. These first 2, and I'm really just saying, okay, so if there's a max of 3 people per team, can I have more than one with 3 people? Let's see, I could if I have all 1s, right? So then I'd say, all right, so one possibility is I have 2 3-person teams, and then I have all 1s. Another is I have 1 3-person team, and then I've got 6 left to distribute to the other 4, and I could either do 2 2 1 1, or well, that's really it, right? I have to get 6 people onto 4 teams. There's no other way to do that. Or I can not have anyone that's a max, but if I don't have any 3s, then I have to have mostly 2s. And that allows me to see that there aren't that many different ways to play the game. So let me show you another example of that. This is one where there will not be a lot of possibilities. So I want you to think about, for this setup, first, do I know some ways to, that this can break out number-wise? There won't be very many. And then are there any other inferences I can make about who or what those numbers correspond to? So take a moment to try this. Okay, so what are we seeing? How many different possibilities do we have? Anyone have one for me? All right, so we can just do all different, 4, 3, 2, 1, right? So if we want to, let's just get our rules down for a second. We know that Quinn presents one more time than Ryan. So we could write that mathematically. Quinn is Ryan plus 1 if you like algebra. Or if we do, if we're trying to count Q, R, S, T, we could just think about, well, how many can really repeat? No one presents more than Quinn. So I know Quinn is the max. Now, could someone present the same as Quinn? Could we have Quinn equal the others? How do we know? How can we tell? And we know T and S go together, right? So if T is 1, S is 1. Well, let me actually say that better because it's a conditional, right? If S, then T. So we know if S is going to be 2, T has to be at least 2. But T could be there times that S is not, right? Okay, so Q needs more than R, but notice it never quite says that Q is more than everybody. It just says no one is more than Quinn. So let's think about it. Like we saw, one possibility is that it's 4, 3, 2, 1, right? So let me drag this out of here. So we could have Q is 4. It's 1 more than R, so R is 3. And then I could have the other two be 2 and 1 in either order. So sometimes we'll do that with what we call a cloud. We'll just put a circle around it and say, hey, it's 2, 1 or 1, 2. Now, another possibility is that Quinn just does 3 and Ryan does 2, but then how many spaces does it leave for everybody else? Five. And how could those 5 break down? Do we have options there? I could have 2 and 3. Yeah, and we might have to think about, are these interchangeable or not? So let's come back to that. Someone's talking about whether we know which one is which in terms of Ty and Shani. So we'll come back to that in just a second. But notice there's nothing stopping one of the people from having the same as Quinn. It just says no one is more than. Now, if we make Quinn any smaller, we get in trouble, right? If I make Quinn 2, then Ryan has to do 1. I got 7 left. There's no way to do that without outpacing Quinn, without having someone do more. So I can't do this. So I know that it's got to be one of these two. And I know that Quinn can't do 5 because then Ryan would do 4 and one of the others would have to be left out. And we know that they are all going to present, right? It says each one is going to present at the conference. Okay, so now let me look at my bubbles, my 2 and 1 for S and T. Can those flip? Someone brought up T is 4. Yeah, we can't have T is 4 in the second frame that we built because then that would be more than Quinn. And we can't have T in 4 as the first one because there's just not the numbers for it. We only have them at up to 3. So we know if T, then S. So if T is more than S, that's going to actually create a problem. So we actually need to put these in a certain order, right? We can get rid of our bubbles. So sometimes I'll put more open-endedness in a game than I ought to. Now, that's not necessarily incredibly harmful as long as I catch it in time, right? So I might set up something like that and then later go, oh, when I actually try to do it, it doesn't work, and that's okay. When I create frames, ideally I would do everything perfectly, right? But in practice, I am not always going to. What I do is I just verify that the frame I'm using actually can create the scenario I'm trying to create. So yeah, so I can have more, I can have, sorry, let me flip that. I can have more T than S. I cannot have more S than T. So sorry, let me flip that around. Okay, if S then T, but T can appear without S. So that's what we're gonna end up with. And notice both times we have to do that. We cannot have them the same. Yeah, sorry, I meant to flip that. Okay. How do we feel about this? Do we see how this could be helpful to have this sort of number frame? Because then when they ask us something, they give us a condition in one of the questions. So hopefully this answers your question, Deanna. Good, right? So if they say something like, if Shawnee presents on Wednesday only, or, you know, if Quinn presents 4 times, or if two of the presenters present the exact same number of times, those are all cues that would tell us which frame we're in and tell us a lot more information about who those are and what we're doing. Okay. Yeah, so this can be really powerful to do. And a lot of people don't think of these. These are sort of like the invisible framework that can be behind these things. It can seem, like I said, like kind of a geeky detail to get into, but it can be a very powerful way to make progress through a game. So someone's asking, why did I flip 1 and 2? And yeah, I kind of flipped that back and forth. I was modeling our thought process a little bit here. But the basic idea is we said, look, I know that in the first line, there's only 3 spots left. So S and T, you know, they can't be 1.5. One's 1 and one's 2. But which one can be which? Well, when we see that if S is in, then T is out, let's look at the contrapositive of that. The contrapositive says that if we don't have T, we don't have S. So if you think about what that means that I can have T with no S, but I can't have S with no T. So T can occur in places where S can't, and not the other way around. The way I often have people remember the relationship between conditionals and contrapositives is with clouds and rain. If you think about clouds and rain, what's the conditional relationship between those? Think about this and this, and this, and this, and then the doubles, right? Which of these are true? Of the 6 conditionals I put, which of these are true about clouds and rain in real life? Oh, did I not put that up? Sorry, there. You can have clouds with no rain, but not rain without clouds, right? So we know if I have rain, I must have clouds, right? There's no way to have rain and not have clouds. So I know that anytime it's raining, there are at least some clouds. That one's got to be true, which doesn't go with a causal direction, right? Rain doesn't make clouds. I mean, maybe it does, but rain isn't why we always have clouds, right? Clouds are why we have rain. But the conditional relationship is different than the causal relationship. The conditional is what do we know for sure, right? And so that's the kind of thing we're trying to look at, right? Just like, for instance, hopefully going to the doctor doesn't make you get sick, but you might know that if you go to the doctor, it's because you're, if you go to the doctor, you are sick. And that's not always true in real life, but imagine it is. Imagine that I only go to the doctor when I'm sick. That would mean if doctor, then sick. The cause might be the other way around. I'm going to the doctor because I'm sick. But the idea is that when I go to the doctor, you know that I am sick. All right. So here, if it rains, I know there are clouds. The contrapositive of this is if there are no clouds, oh, sorry, did the wrong one. If there are no clouds, there's no rain. These other ones are not things that we know. So using this to help you remember can be useful. It's this idea of, look, I can have clouds without rain, right? So I don't know that if there are clouds, there's rain. I don't know that if there's T, there's S. I can have T without S, but I know if there's S, there's T. I can't have S without T. So this tells us that they're either equal or we have more T than S. Does that help? Because anytime I have S, I have to have T, but I could have T by itself, right? Anytime it rains, I have to have clouds, but I could also have other days where there's clouds but no rain. So if there's more cloudy days and rainy days, that's possible. If there's more rainy days and cloudy days, that's not possible. That's not a thing we can really have. Does that help that on that one? Oh, sorry, someone's asking, I'm new, what does the squiggle stand for? Thanks for asking that. The squiggle in this case is what we're using for it to mean not. So squiggle T just means if not T, if not S, if not clouds. Yeah, thanks for asking. So that's a negation. We're saying if If S appears, T appears. If T does not appear, then S does not appear. Sometimes means it is not the case that. Okay, other questions on that? Some of us just use a negative sign, which is clearer for those starting out. Okay, let's try this again. Let's do another setup with some number arrangements, see what you can do. Okay, let's see what we can do with this. So the way we would set this up if we were doing a logic game is we'd write the names of the elements. And so I didn't do this last time, so I'll show this time. L, M, N, O, P. Interesting book subjects for sure. And we've got an 8-week class. So we know we have 8 spots. We don't know a lot here. And again, the point here is less about setting up a realistic logic game and more just about thinking about these possibilities. And the rule we have, a chapter for the book on mindfulness must be assigned in any week preceding a week in which a chapter from nepotism or patriarchy is assigned. How would you write that rule down? Before we worry about numbers, how would you write down that rule? So we got MP or MN. Yeah, now that's an interesting thing. So some of you are doing a conditional. So tell me about that, right? A few of you said, hey, if N, then MN. Why add that conditional, right? What's the difference between saying if N, then M is before it, versus just saying, hey, MN? Which one do I want, or are they the same thing? So first off, I don't always have to have N or M after M. So in other words, maybe I have a mindfulness chapter right at the end, right? Maybe I have a mindfulness chapter right at the end and it's not followed by N or M. So it's not that every time I see M, I have to have N. In fact, that would be impossible because of course we also know that anytime I have P, I have to have M, and I certainly can't have both of them come after unless I had, a stacked kind of situation where there's multiple chapters in one week. So these aren't the rules we want. We want these conditional rules. And one reason for them is that M does not have to be followed by either of those. The other is that in a game where potentially some of the chapters weren't going to get assigned, maybe they weren't ever going to have book N, then this chunk would never occur. So we also have to say, if there are a possibility of an out, which we're going to talk about in a minute, the idea of an out column. If there are a possibility of an out, then maybe I would want to have N out and not ever have that MN chunk. Does that make sense? Okay. So that's what we want to watch. We want to watch the conditional because what it's saying is if you do this, then that has to happen. It would be like if I said, hey, if you want to go to law school, then you have to take the LSAT first, right? But that's only if you want to go to law school. A lot of people don't want to go to law school. I would say most people don't want to go to law school or don't plan to, right? They don't have to take the LSAT at all. And they don't have to go to law school. They don't have to do those things. So it's, if you want this, then this precedes that. If you don't want that, then don't worry about that rule. Don't apply it. Don't use it. Okay, that makes sense? So then we can think about numbers. I've got 5 elements to fit in 8 weeks, and it does say chapters from each of them are to be assigned. So that's important to notice. There's no 0, and we always have to watch for that, because otherwise we might have something like an out. But here they're all going to be assigned. At least all books are going to be assigned. What are my numbering possibilities here? What's the maximum any one book could get? Okay, so I could have 4. If I have 4 of one, then everything else just has to be 1, right? And yeah, I just put learning size as LS. It's one thing, so we're not worried about using more than one letter. We can if we want, but it's not necessary. Right? Okay. So then we have to think about, is this possible, right? So if I'm going to have 4 of one, do I know which one it would be? Right? Well, first off, they've said none of them can be more than 3, right? So we really have to max that out at 3. Okay. So if one of them's 3, what are my available numbers for the rest? So I can't have 4 because of a rule, right? It just says no book will be assigned more than 3 weeks. So watch that. Sometimes there are rules up in the initial stimulus that we kind of pass over because we're looking at the individually stated rules after. We have to go back and make sure we've got our setup. So just make sure that what you're doing fits what the constraints are that they've given. If I have 3, what else is left? What can I have? 2 on 1. Yeah, there's a total of 5 left and 4 spots, so I just have a 2 and then 1s, and that's the only way to do it. We can talk about which where, but that's the only way to do it. Now, what if I don't have a 3? What else can I have? If none of them are 3, if the most I have is 2, what does the rest look like? Yeah, I'd have to have 3 2s. That gives us 6, 7, 8. And if I don't have any 2s, there's no way I can get more than 5 total assignments. So I'm stuck with that. Notice I only have 2 possibilities, and even of those 2 possibilities, I can start narrowing down. Do I have a sense of what the 3s or the 2s might be in some of these? What do I know? Yeah, at the very minimum, I have to have an MP and an MN. So if there's two of something, which there always is, right? M at least has to be one of those twos, right? So the M must be 2 or 3, right? Is there anything that could not be the 3? And someone says it can't be 3M. Why not? Yeah, N or P can't be the 3 because there can't be more N's than or P's than M's, right? And P can't be 3. And in fact, they can only be 2 if there's a 3, right? So in this arrangement, we'd say, hey, M must be 2 or 3, N or P can't be 3. In the second one, we'd have to say N and P can't even be 2, right? So we could know that N and P have to be 1 and 1, because if either of them were 2 in the second arrangement, then that would be 3 M's, which we can't have in that arrangement. So if there's no 3's, then there's only 1 of N and only 1 of P and 2 of everything else. So we could then know there's 3 M's, there's 3 L's, and there's 3 O's. Or sorry, 2, I should say, speaking clearly. Whereas on the first one, M could be 2 if N and P are 1's, or if N or P is 2, then M has to be 3. So it gives us a little bit of a framey feel without being a full frame. Okay. How do we feel about that? That all right? Okay. So I want to get to another principle I alluded to earlier in terms of just a speed strategy, and this is working with an out column. An out column is a very powerful thing to be able to use, and the smaller it is, the better. But the basic idea is when you have a number of things that are either in order or being put into groups, if you know that some won't be selected at all, that's often the most important thing you can know, because usually there's more in than out. And the smaller an out column is, the more powerful it is. Because if I know that only, like, let's say I'm selecting 6 out of 7 toys to play with, right? That means once I know which toy I'm not playing with, I know all the ones that are in. It drives everything else in. And even when I have 2 or 3 outs, it can be very powerful because once I know what's out, it fills in a lot of the other decisions that I have to make. So let's set up a game here. I'll give you a second to play with this. And it's going to have an out column. And so make sure you're drawing your out slots along with your in ones and thinking about how those influence the game. All right, so let's think about how to draw this. We know we're selecting 4 out of 6 ads. So what I'll generally do when I'm setting up a game is I'll write the elements out, P, Q, R, S, T, V. And I know that this is an ordering game. because they tell me they're talking about the first add, the second add, third add. I also want to think about my outs. And so what I'll usually do is I'll just separate that out visually. If it helps, you can write the word out, or you can just know that that vertical line means out to you. And we'll say, okay, I'm going to have spots 1, 2, 3, 4. Some of the rules are easy to write. T cannot be the third add shown. I'm just going to cross it out under the 3. If they said T were the third add shown, I could just write that right in. We know if R is selected, then S is directly after it. So we've seen this rule before. If R, then RS. And then they have if P is selected, it's first, and if Q is selected, it's first. And obviously these are inconsistent, right? They both are true rules, but they're inconsistent with one another in the sense of they can't both be triggered at once. So we know that if either of those is in, then the other's out. So if P is first, if P is in, P is first, but then Q is out. And if Q is in, then Q is first, but P is out, right? So we could just kind of do this. Another way to write it other than the squiggle is just to cross out. So would it then be fair to say that P or Q is first? No, interesting. Why not? Ooh, they could both be out. They don't have to be first, right? I think about a very unlikely thing, right? What if I say, you know, if Beyonce comes to my birthday party, she'll bring a nice present. Okay, maybe, but like, is she coming? No, right? So, you know, it doesn't have to be a likely thing to happen. But I know that they could both be out, and I know one of them must be out. They can't both be in. They're not consistent with each other. So what I can actually do is I could have a placeholder on my out column. I know that one of P or Q are out. Possibly one of P or Q is in, but I know that one of them for sure is out because they couldn't both be in. Either one being in would be first, and there's only one spot in first. There's no tie. Okay. Because the TV can't run 2 ads at the same time. In other cases, it could be, you know, there could be 2 bands performing at the same time or something like that, maybe. But here they've made that clear enough without having to say no ties. So that's interesting. We have a placeholder. Now I hope you can see where the out column can get very powerful. As soon as we know that someone else is out, we know everyone who's in, right? So for instance, let's say I know that R and S are in 3 and 4. Let's say that's what one of the questions tells me. What can I do with that? So I could have T and V. I could have P or Q in, right? So either I have P or Q in and then one of T or V. I could think of it as a frame, right? If P or Q is in, it's here. And then I have one of T or V here. Or I have P and Q out. And then I have T or V like T and V like this. So I can think of this as sort of a mini question specific frame. So it can be things like that. That's right. T is not in 3, but that one doesn't get triggered anyway because we already know R is in 3 in that case, right? If T could only be in 3, let's say we had that rule. If T can only be in 3, then when R and S are in 3 and 4, we know to put T out and we'd have our out column filled and we put everything else in. So there can be ways to play with that like that. So depending on what they tell us, we can make different kinds of inferences, right? So what if they said something like, you know, if T is after RS, right, or something like that. And then you say, wait a minute, if T is after RS, then either I have RST, which is not possible, or I have RST, or what's my one other possibility? No, if the question says T is after RS, right, then it can't be first or out. What would be my other possibility? T could be fourth, but with R and S first and second. So I could have RS space T. It didn't say directly after RS. So sometimes I'll have things like that where the rules combine to tell me, oh, I have T fourth no matter what, and then RS are in 1, 2 or 2, 3, right? That doesn't automatically give me an out. Other things might. Maybe they tell me that V is in fourth and RS are in 1, 2, and then T can't be there. T would be another out, things like that, right? Although at that point we're running out of elements to place. So that could be a problem. Okay, questions on that? All right, let's grab one more principle that can be interesting, which is the principle of who's left. So I'm going to give you kind of a complex one to diagram. So just give you a minute to play with it, and then we'll try putting it together as a group. So play with this, and I want you to specifically think about it as you diagram this one. And if you're new to this might be a little overwhelming, so you can just go for it with us. What you want to think about is, once I've filled in the things that I know, what's left to think about? What other elements can I place? So give this one a try. All right, how are we doing with this one? Is this one tough? A lot going on here, and I hope we could combine some of the things we talked about briefly. So first off, if I've got 8 people in 3 groups, ignoring all the specifics about who's in what group, what are my numbering possibilities in this case? Yeah, there are other possibilities in theory I could have. If I have 8 people in 3 groups, in theory, I could have, 6, 1, 1 or something like that. But they've told us that the groups have 2 or 3. And since the only way to get 8 is to have 2 2s, 2 3s and a 2, we know that our arrangement is 3 3 2. And that makes it easier since we're also going to be dealing with some ordering stuff, which is kind of obnoxious, right? So we've got F, G, H, J, K, whoops, F, G, H, J, K, L, M, N. And I've got 3 groups, P, Q, R. And then just to be obnoxious, they also want to know who's first, second, third. And so you have to think about ordering the groups. So there's different ways you could do that. You could have 1, 2, 3, and then order around what's considered P, Q, and R. Or you could have 2 separate charts. So there's a few ways you could do it. But let's just start putting this down and seeing what we know about these. We know that the group with the fewest number of students can't finish first. So we know that there's 3 in this group and not 2, right? Okay. So then what else do we know? F finishes ahead of G. So we'll do what sometimes call exclusions. We'll say, hey, G is not first and F is not last. H and J are in the same group. So H and J are what we call a chunk. They're together. And notice since we only have 2 or 3 in a group, we know that either H and J are the entire group, they're a team to themselves, or they have one other person with them. So we could kind of have like another spot on top, like, hey, maybe there's a third person. K and L are in different groups. So one way to write that would be an anti-chunk. K and L are not together. G is in group P. Finally, we get a specific assignment. What we'll usually use to indicate group size is we'll say, all right, if I know that I have to have 2 in each, then I'll make boxes to show that these are mandatory. I have to put 2 in each group. But then I don't know about the third spot. Sorry, those are a little wonky. I don't know about the third spot, so I'll leave an opening for a third one. So that what this says is each group must have 2 and may have 3. So I know G's in group P. F is not in group Q. Okay. I could try to do that to figure out where Q goes. All I know is that F is not in group Q. So I know the group F is not in can go third. The group F is in cannot go third. So I can't really figure out where Q is at this point, unfortunately. M and N are in different groups and neither of them is with G. So I can say, hey, I know M's not with N, M's not with G, and N's not with G. And if I wanted, I could also, and I'll just be lazy and not box those, but just say those are out. If I wanted, I could also write above the F before G that N and M are not there. Okay, but I already know where G is. So I can knock some things out here. I can say, hey, there's no M here and there's no N. Okay. So if that's the case, what do I know about where M and N are? Yeah, they've got to be in the 2 groups. There's no out column this time. They're all the classmates are being assigned. It says so. So what I know is that M is in either Q or R and so is N. So I could do M/N, or what I sometimes do is what we call the cloud. I'll just put a circle around this and say, hey, one of these is here, one's there. Okay. So then I think about, well, who else is there to place? I know I have to have the HJ chunk. Do I know where that goes? I don't know much. It looks like it could go anywhere, right? HJ could fit in any of these and make a 3. But wherever HJ goes, it makes a it makes a complete 3. Someone's saying not last. Why not last? Yeah, we know the first one has to be 3, and the other two, one's a 2 and one's a 3. The 2 doesn't have to be last. We just know that it can't be first. So we have a 2 and a 3 that could be in either order, right? So the 2 will either be last or second to last. So we kind of got this, but we can start thinking about who else is left. So I know I could make an HJ somewhere. So then what we think about is who's left. If I say, all right, let's kind of run down the list. I'll even cross out for a second. I'll say I've placed G. I've written M and N in. I know that H and J are a chunk, even though I don't know where they are. I know F, I know where it's not in Q. So I have F, K, and L. Do I know anything about what to do with those? Okay, someone's saying F's in R, why? Why can't F be in P? I know it can't be in Q, why can't it be in P? It has to be before G, interesting, so it can't be with G, right? So notice one thing with who's left is like, really who's left to go in with G? F is before it. So that's a rule we might not have thought about, and I'm glad some of you thought of it, which is that if F is before G, then they can't be together. So we've got a lot of what we call anti-chunks, and that creates some really interesting inferences. So now I know F is here. And now I say, all right, well, let's see. So what do I know about HJ then? HJ can't go in R, there's no room. And then what's left to place? K and L. Why can't HJ go in Q? Can we prove that? Let's see, okay. So I know HJ can't go in R. Then I have K and L to place, and if we think about this who's left idea, we could say, all right, well, if K and L have to go in 2 different spots, and they can't go with HJ, then I've kind of got this spread where I've got HJ in one spot, and then K in another spot, and L in another spot. So one way I could think about then is to say, all right, I've got K or L here, because I can't have H or J. And then the other 2 spots, in one, I have K or L, and in the other, I have HJ. And so one way to think about this, I know I'm being a little sloppy, but this happens on test day, unfortunately, is we can kind of go like this. One of these has HJ and the other has K or L. And then we still have to think about order, right? Which one comes first, second, third, and that might come up later. This is a very involved game, as we said. So maybe you'll sit down with this later and see some more inferences in this. All these things that we're doing are from our 5-pound book. So if you want to get a copy of that, you can see these drills. So would I frame this? Yeah, I might. But in a sense, I kind of already have, in the sense that there's not much more to do. The question would then be, what's first and what's second? So that's what you'd have to think about, right? So basically what we can see is either P or Q has the 3 and the other has the 2. And I know that whichever has a 2 isn't first, but I don't know what is first. So I don't know if I could really frame that. I think I would rather just leave it as is and say I have most of what I need. Okay, thoughts on that? So these are a lot of principles. I hope you find them helpful. So in addition to the broad framework of speed techniques for logic games that we talked about in our initial speed strategies lesson, we also talked about a few specific things for games: framing, number arrangements, using an out column, and asking yourself who's left to place and where can they go. And often you'll get this sort of standoff. We called it in the book sometimes an anti-chunk standoff. If I know that K and L aren't together and there's only 2 spots left, I know it's okay, K is here and L is here, vice versa. So sometimes things are forced into specific spots because of a rule that another one has, right? Oh, well, H and J have to be together, so I have to separate these other 2, right? Or K and L can't be together, and since they're spread across 2, I can't put these other 2 together. There's no more room. And so you end up with a lot of restrictions on grouping games when that happens. All right, everybody, stick around if you got questions. Other than that, I hope this was helpful for you. And best of luck with your studies. Thanks, everyone. Have a great night.